Omo.
I can't ban.
Well, hello everyone. Welcome to week 7 C++. I am Emmanuel. And you're going to do it. You're going to do it. Functions for today. These are our learning objectives for today. Like functions, function declaration and definition. As you can see here, our slides and decrease the function. And we're there with argument, passing, default argument, then our user defined functions, which are the types of functions. Now let's begin. Now be like, what's a function? Well, think of a function like a recipe in the cook book. Just like a recipe has a name, ingredients, and step-by-step instructions to make a dish. Function has a name, parameters, and code that perform a specific task also, like a function. So we define function as blocks of code designed to perform specific tasks. They are fundamental for organizing code, promoting reusability, making programs easier to manage as functions. In C++, functions are blocks of code designed to perform specific tasks. They are the fundamental building blocks that help us organize our code, make it reusable, and keep our programs manageable. Imagine you are building a house. Instead of mixing cement, laying bricks, and installing windows all in one huge process, you break it down into smaller tasks. Functions work the same way. They break down complex programs into smaller, manageable pieces. Let me explain types of function you will encounter in your C++ language. You have the user-defined functions, standard library functions, you have the virtual functions, and the inline functions. Let me break down this for you. So when you talk about user-defined functions, what are they? These are functions that you, the programmer, you create yourself to solve specific problems. Think of them as your custom tools. For example, if you need to calculate the average of three numbers repeatedly in your program, you would create a user-defined functions to do this. So they are created by the programmers to perform specific tasks. We have standard library functions as our next point here. In the standard library functions, these are the pre-built functions that come with C++. Like having a toolbox that's already filled with useful tools. As an example, we have the std cout, which is for output. We have the std square root, the sqrt, which is for square root calculations. We have the max. We also have the max, which is for finding the maximum value. Our next type of function, we have the virtual functions. Virtual functions, don't worry too much about this. Cover them in advanced topic, but they are used in object-oriented programming for something called polymorphism. Functions in base classes that can be overridden in derived classes, enabling polymorphism. That are the virtual functions. We also have the inline functions. For the inline functions, they are functions where the compiler tries to replace the functions, call the actual functions code to make your program run faster. Just think of it like copying, pasting the function code wherever it is called. That's the inline functions. Well, why should we use functions? Why should we use functions? Let me give you 4 compelling reasons why we should use functions. Benefit of functions. On the first point, we have the modularity. Modularity. Functions help you break down complex programs into smaller, manageable units. It's like organizing your closet. Instead of throwing everything in one pile, you organize clothes by type, season, or color. That's what we call modularity. We also have the reusability. Look at reusability as a benefit of function. We mean you write once, use many times. That's the reusability. If you create a function to calculate tax, you can use it whenever you need tax calculation in your program or even in another program. Now, next point, we have abstraction. That's the next point for benefit of functions. Talk about abstraction means functions hide the complicated details and let you focus on what the function does, not how it does it. When you use a calculator, you don't need to know how the circuits work. You just need to know that pressing the addition sign add numbers. That's what we mean by abstraction. Our last point, we have improved readability. Improved readability. Functions make your code easier to understand and maintain. Instead of having one massive block of code, you have clearly named functions that describe what each part does. That's the last benefit of functions that I have on my list. Now, let's move on to functions. Function declaration. Talk about function declaration. What are we talking about? Function declaration is like announcing to your program, hey, I'm going to create a function with this name. It takes this input and returns this type of output. That's what we mean by function declaration. It's also called a function prototype. As you all know, think of it as a preview or a promise. You are telling the compiler what to expect before you actually write the function. So the syntax, we have the syntax as this: return type of function, function name, the parameter 1, the parameter 2. So let's see the actual code. There's the actual code here. Start by hashtag include IOStream using namespace. You start by the basic structure of C++, then int find sum, the first number, then the second number, then you output. Use the cout is for outputting. So find sum, the 1 and 2, which is the first number and the second number. First number and the second number. But you should note, one thing that you should note here is the find sum. Notice how we declared the find sum before using it in the main. Even though we haven't written that, we haven't written what it actually does yet. You should notice the find sum. So we are moving on to the function definition. Talk about function definition. What do you mean? Function definition is where you actually write what the function does. Like going from a recipe title to writing out all the ingredients and steps. A structure. Function definition includes a return type, a name, a parameter list, which is optional, and a body enclosed in the curly braces. Now, the return type, what does it do? Return type is what kind of value will this function give back as a return type. The function name is what do we call this function. You have the parameters, what input does it need. You have the function body, what does it actually do. That is the structures. You can have a look at it. Function definition structure here. Definition structure. We have this also here. So let's explain the keywords again. We have the return type. This tells us what kind of data the function will give us back. And use void function. If this function does not return anything, then we use the void function. Function that just prints something to the screen. That's when we use the void function. Return type. Function name. We talk about function name. This is how you will call the function. Choose meaningful names like calculate average instead of function 1, function 2, function 3, function 4. You will get something that's unique, or the function that's talking about what you are doing. The next thing we have the parameters. These are the input your function needs. Let's think of them as the ingredients in a recipe. We also have the function body. The function body is where the actual work happens. This is the step-by-step instructions. You also have the return statement as the last thing. This sends a value back to whoever called the function. These are an example of the code or the structure of the code. Function definition. Have a look at it. You can try it on your own. While you are going through the studies, you can try it on your own. Try it on your own. And we have parameters versus argument. We talk about parameters versus the argument. Now we'll talk about parameters. What are they? What are parameters? Parameters, most of the time students are confused between the parameters and argument. What is the basic difference? Parameters are the variables in the function definition. They are like empty boxes waiting to be filled in our function definition. So variables in the function definition that receive the argument are parameters. In the syntax, return type, the name, type 1, type 2, 1, type 2. And let's talk about the argument. Talk about argument. What are the arguments? Are the actual value you pass when calling the function. They are what fills those empty boxes that you created as parameters. So arguments are what fills the parameters. That's the difference. Arguments fills the parameters. So think of the parameters as placeholders and arguments as the actual values that go into those placeholders. So they are different that goes into these placeholders. You should know the difference. Parameters are the placeholders or the empty boxes, and the arguments are what fills the empty boxes. I hope you understand. This is the structure, function, name, argument 1, argument 2. We have different types of arguments. So talk about this argument. We have the value argument, reference argument, pointer argument, then array argument. For the value argument, you pass the actual value. The reference argument, you pass a reference to a variable. For pointer argument, you pass the memory address, and for the array argument, you pass an entire array. And we have default argument. Let's talk about default argument. The default argument, sometimes you want to make a function flexible. The default argument lets you provide default values for parameters. So users don't always have to provide every argument. That's the default argument. It's like ordering at a restaurant where the chef has a default seasoning. But you can specify something different if you want. That's your choice. Have a look at the structure here for the default argument. Structure, notice how you call the get sum. Can check the code here. Notice how you call the get sum in our code, and it automatically uses 20 for the second parameter. That's the default argument. But we can also call get sum 5 and 15 to override the default. Yeah, that's it. Let's move on to function calling. Function calling. It's another one. Let's move on to function calling. Talk about the function calling. To execute a function, you call it by its name, followed by parentheses. Fuck you. Followed by parentheses. Followed by parentheses. And any required argument. To use a function, you call it by its name, followed by parentheses and any required argument. It's like calling someone's name to get their function. As a simple something, so syntax is a syntax. Is a syntax. So next thing is function overloading. So function overloading is a powerful feature that lets you create multiple functions with the same name but different parameters. That's the function overloading. It's like having multiple tools with the same name but different purposes. Why would you want this? Sometimes you want to perform the same basic operations like adding numbers but with different types of data or amounts of data. You can overload functions. So defining multiple functions with the same name but different parameters. You can overload functions in 3 ways. And the first way, we have by different number of parameters. That's by having different number of parameters. You have the second one, you have by having different types of parameters. And the third one, you have by having both different number and types of parameters. Both the different number and different types of parameters. That's the third way. So look at the case 1, having different number of parameters. There is it. You have the return base, int add, int A, int B. We have return A plus B. We have add int A, int B, int C. Add this. That's the first one, different number of parameters. So here we have two parameters here, and here we have three parameters, the A, B, and C. And the first one we have two parameters. We have three parameters using different number. And let's have a look at the second type, case two. Case two is different type of parameters. Case two is different type of parameters. Here we have int A, int B, we added, and here we're using the integer function here, integer data type here, and different. Next one we have the double add, we have double A and B, so double. So we are using different type of function. And let's have a look at the case 3. We have both different type of function and different number of functions. So here we have the integer add, we have int A and double B. They are all different, integer and double function here. And here we have double A, int B, int C. They are all different. And here we have two parameters, int A and double B. Here we have three parameters, which is the double A, int B, int C. Now let's have a look at your assignment here. So with 7, you write your given assignment. Now previous lesson we dealt with GPA calculator. Now I would like you to apply the application and use the functions in your code if you didn't, or if you couldn't use the function in the code. So summary, let me summarize everything for you as we are ending with our session. We covered what functions are and why they are important, how to declare and define functions, the parameters, argument, and